I'm now going to show just how easy it is to write automated unit tests to test a function that you've written. Now you can write the function and then the tests, or you can write the tests and then the function, which I'm going to start off doing. The function I want is, I'm just going to call Pythag for Pythagoras, and it's going to calculate the hypotenuse of a right-angled triangle. So let me start by writing a test. So just the letter T will pick up a test frame. And I have the option of giving the test a name, but I don't have to give any of my test names. I may add some later if I write more. Now, the most important new type of frame within a test is the assert, and I'll pick that up with an A. And I have to, first of all, get a result. So I'm going to have a function called Pythag that is going to take two values. So if I were to give them both 0, I would expect the result to be 0. Now, as I move off that, it's going to give me a compile error because Pythag doesn't yet exist. Pythag is not yet defined, but I can ignore that for the time being. So I'll do another assert with a different case, and I'll just do the 3, 4, which is the obvious because I should expect that to return 5. And again, I'm going to get the compile error. Now I'm going to write the function itself. So F for function, call it Pythag. And that's going to take two sides, B and C, both of type float, C as float, and this is going to return a floating point number also. And just to get the thing off the ground, I'm just going to make it return 1 instead of doing any calculation. And as soon as I hit enter or tab off that field, you can see it has compiled now because Pythag is a known function, and both of the tests have been run, and we've got a test failure. Any single test failure, any single assert failure in a test will cause a test failure. That's the convention in unit tests, and it's telling me that though I expected 0, I've actually got 1, and that's not surprising. So let me now immediately go back down, delete that 1, and actually write the thing properly. So what I want is the square root of b raised to the power of 2 squared plus c to the power of 2. And as soon as I hit enter on that, it compiles and both tests pass immediately. So you get this immediate feedback, and you can see the test status overall is green. So let me just write a couple more for good measure. Make sure that a negative number works. Minus 5 with 12 should give us positive 13. And that, you can see, passes straight away. And then I'll do one that involves some fractions. And I'll do 3.1 comma 4.2. And in my head, that's going to come out at something like 5.22, I think. And actually, it's 5.22 and a whole lot of other digits. Now, I can either update this test to copy that, but we're not trying to test how accurate the built-in square root function is. We're just testing that our logic is correct. And so a better option for me here is just to say, I'm not going to test the result itself. I'm going to test the result rounded to 2 decimal places. And now that's a pass, and all my 4 tests are passing, and I can proceed. Now, it's very good practice to write tests for every single function that you write. It'll give you much more reassurance. And another nice feature is that if I load up a program that I've written previously and it has tests, then as soon as I open that program, it's going to parse the file, it's going to compile it if it parses, and if it compiles, it's going to run the tests. And I've got tests down here. Now, these values aren't saved. It has run this live, and so I get the immediate reassurance that this code, which I was working on yesterday, is still valid. I left it in a valid state and it's still working.